Ever wonder what's going on deep beneath the Earth's surface during a massive earthquake? This paper dives into the 2023 Turkey earthquakes using something called shear-wave splitting to get a glimpse.
It's like having a super-powered ultrasound for the Earth, revealing hidden structures and stress patterns.
So shear-wave splitting, what exactly is that?
When an earthquake happens, shear waves travel through the Earth. If the Earth isn't uniform, these waves split into two, revealing clues about the rock's structure.
And that helps us understand what happened during those devastating earthquakes. So let's talk about these Turkey earthquakes. Doublet earthquakes, what does that even mean?
Two massive quakes, close together in time and space. They really shook things up, literally.
Right, and this study focused on the area around the epicenters?
Exactly. They looked at seismic data from 10 stations around the fault lines, trying to map out the stress.
How did they actually collect this data? Did they use some super secret underground sensors?
Not quite secret, but sophisticated. They used seismic stations, which record ground motion. They analyzed data from before and after the quakes.
Wow. And how did they analyze the shear wave splitting? Sounds complicated.
It is. They used a combination of visual inspection and a computer program to measure the splitting parameters, the direction, and the delay time of the waves.
So what did they find? Did they find anything surprising?
The fast wave polarization direction, that's the direction the faster wave travels, strongly correlated with the regional stress field.
Interesting. So the direction the waves moved revealed the stress direction?
Precisely. And they saw variations across the study area, showing how stress wasn't evenly distributed.
I see. Like some areas were under more stress than others?
Exactly. The middle of the fault line, where the main shock hit, showed much greater delay times, indicating higher stress.
Did the stress change over time?
Absolutely. Before the quakes, delay times were low. They spiked after the quakes, then gradually decreased as the stress released.
So the Earth was kind of breathing out after the initial shock?
A good analogy. The stress adjusted and the wave splitting reflected that.
This all points to anisotropy in the Earth's crust, right?
Yes, the Earth's crust isn't uniform. It has different properties in different directions. The shear wave splitting highlights this.
Right. And how deep did this anisotropy extend?
Mostly in the upper crust, the top 20 kilometers or so, based on the aftershocks and previous studies.
This is all fascinating, but what does it mean for our understanding of plate tectonics?
It shows how the movement of the Arabian, African, and Anatolian plates creates complex stress patterns. The earthquakes are a direct result of this interaction.
So this research helps us understand the why behind these earthquakes.
Exactly. It gives us a more detailed picture of the stress buildup and release, which is crucial for earthquake prediction and hazard assessment.
Were there any limitations to this study?
Sure. The number of stations and the shear wave window limited the resolution in some areas. Some stations had very few usable events.
So to summarize, what were the key takeaways?
Stress wasn't evenly distributed before the quakes. The middle of the fault line had the highest stress, and stress patterns changed significantly after the quakes. The study highlights the importance of anisotropy in understanding earthquake processes.
That's really interesting. It's like a window into the Earth's hidden stresses. What kind of future research could build on this?
More stations, longer recording periods, and combining this data with other geophysical techniques could provide an even clearer picture.
How can this research help people in earthquake-prone areas?
By improving our understanding of stress patterns, we can better assess earthquake hazards and develop more effective mitigation strategies.
This is all incredibly complex, but it's also really cool. It's amazing what scientists can learn from these seismic waves.
It's a testament to the power of observation and analysis. We're constantly learning more about our planet's dynamic processes.
Absolutely, and that's why this research is so important. This has been a really insightful discussion. It's amazing how much we can learn about earthquakes by studying shear wave splitting.
It's a fascinating field, and there's still so much to discover.
That was a great discussion. Thanks for sharing your expertise.